everybody to my AP biology tutorial on YouTube. I'm going to be talking about meiosis. I'm saying meiosis. I would really appreciate it if you would like and subscribe for more content. And don't forget to use the little ring notification thing. And please subscribe to the channel so we can get um, Mr. Ham's Biological Institute or whatever. I got hired for this. I'm getting underpaid. To 100 subscribers, that would mean so much. Anyway, we're here today to talk about meiosis, and we're going to be going through the basics of meiosis. And one of the first things that we need to clarify when we're talking about it is that we are pretty much talking about sex and body cells. So it's like there are a bunch of different names for these types of cells. So for sex cells, it's going to be a 1N. It's also referred to that. It's also referred to diploid, and it's also called a gamete. And I'm going to be getting to the differences in just a little bit. We've got body cells, so it's 2N, and this N is essentially saying that there's going to be like a normal amount, like 2 sister chromatids, and we're going to have haploid, and we're going to have somatic cells, and these are like the main names that we're going to be using in AP biology, and it's pretty important to know. So somatic cells are going to be similar and akin to like skin cells, your skin, your liver, your eyeballs, pretty much any part of your body that's been like duplicated normally with just like regular mitosis. However, we have the sex cells, which is what we're going to be talking about in particular today, and what meiosis is all about, which is the sex cells. So it's pretty much just the sperm and like the egg, and the special thing is that I meant we're going to be talking about the sex cells, right? So it's like the sperm and the egg. Sorry, I got mixed up. And these are pretty much half the DNA in order to create a new human being. Let's say if we have like a full jar here and a full jar here, like this is your mom and dad, let's say we're having another full jar, and each full jar is a human being. And mom and dad has a lot of stuff to give. They each need to give half. So the child himself is a genetic combination of the mother and father. But you can't just have like the full jar from both parents. That'd be crazy, because humans have a specific amount, 23 chromosomes. But not all animals have 23 chromosomes. Like a mouse has like significantly less and so on. But for humans, we talk about for 23, because that's what matters. I mean, genetics in general, we don't really focus on like the number of chromosomes, although the same rules apply. We just talk about humans. I don't know. It's high school. We don't care. So, the process in which the cell, because all cells have 23 chromosomes, right? Just regular body cells, they just have 2N. But in order to get to the singular N, takes an entire, it's an entire process called meiosis, and that's what we're gonna get into today. So it all starts with one body cell. I'm gonna make it nice and big, and we have the regular cell. These are some sister chromatids, some chromosomes, and over here we have spindle fibers going on over here. So it starts like when we look at the life cycle of what's going on in the cell, we have like just growth 1, which is like the cell just growing regularly. We have the S phase. S phase is important, and this is important because that's when it starts actually multiplying its DNA in half to get ready to divide into two cells because that's what's going to happen. G2, it's the same thing as S phase except it's for all the body stuff going on. I mean, technically, it's not. What I meant is that G2 is just like the ribosomes, like all like the organelles in the cell needs to be divided, but the S phase has its own thing because DNA needs to be divided like just on its own. And then we have like this tiny, actually technically interphase is only this much. We have this tiny little section called interphase, and the interphase is broken up into like 4 different sections, and these 4 different sections is where it starts off. So if this is interphase, then it goes, to the S. Yeah. So it goes interphase, then prophase. Nope. I'm sorry. This is interphase. Yeah, this is all interphase. This is how interphase starts. Yeah, my bad. And the 4 sections, it starts with prophase. Then it goes to metaphase. Then anaphase. Then it ends with our favorite. Did I mess this up? I don't want to mess it up. Please don't. Metaphase, prophase. Telophase, of course. Telophase. I'm not going to be going into detail because this is just a quick review video for our YouTube channel to get the youth interested. But it's pretty much the essential gist is that we're going to be starting with the cell that's ready. It's prepared itself. It's prepared itself to divide, and it has all the materials it needs. It just needs to break up these sister chromatids in the middle, split them up like so. It'll go to the side, and then the cell starts splitting in half, and eventually you have 2, with the same amount of DNA as a normal body cell would have. If I did this wrong, I'd be so mad. And yeah, okay, now here's the thing when it gets to meiosis. This funny thing about meiosis is that these regular cells, the end goal of meiosis is to have 4 daughter cells. We're going to have 4 daughter cells. And when it gets to the actual meiosis, this is called meiosis 2. And the reason it has its own name, and the reason this part has its own name is because these cells don't go through the regular life phase in the right phase that the body cell did, because remember, the parents want to give only half their genetic stuff over, and we want each of these to have exactly 1/2, so that if this is the dad, and then again we have if this is the mom, and we go that I'm just gonna make this really quick, and then like this has to be 1/2 as well. So when these combine, we're gonna have a product of a full cup for the child. So, man, I really did all that. I've gone too far. I have to make this black. I put too much work in. I have to make this black. There we go. 1. Oh my gosh. Other people are doing Twitter accounts, and I'm here making my 1 black. Okay. And that's why we have this. And this is all meiosis, that's meiosis 2. And the most important thing to recognize is that during these cells, I actually did this on purpose because there's only going to be 1 of each sister chromatid, because each of these is just going to be like half of 1. If we reference an image, which I actually don't have on hand because I did this on the fly, I usually have images on hand. I'm sorry, I'll do that next time. But each of these is just gonna have 1 of that sister chromatid. Technically, okay. Like I said before, humans have 23 pairs of chromosomes. Like if you look at a karyotype, it's like 23 sections. But in each section, there's 2. Think about this, okay? Like if this is a human cell, there's see this line, this line. There's technically 23 of those. It's just not in a pair. It's just a single sister chromatid. When you put them together, they're gonna be like a pair of 23. So that's why there's like we just look at it as one, so it's pretty simple to draw. And it's just gonna be the half, and the half makes the full, the one. And that pretty much summarizes meiosis pretty well. One of the most important things when it comes to meiosis and ideas like this is crossing over. Now, crossing over is pretty much the idea that gives us genetic variation, like it's like the reason why all humans are different, and all of like humanity came from like just a couple of cells, but why are we all different? It's because of this crossing over. So what it does is that, let's say we've got these two chromosomes. What crossing over allows is that these chromosomes are like literally going to cross over themselves and give each other certain material that like will allow it to pretty much become like transformed. So it'll like look like this, and like I don't know how to really describe it with words, but like as you can like see over here, it's just kind of like mixed. So like this one has a bit of like the other person's, and this chromosome has a bit of the reds, and that's just crossing over. Crossing over actually occurs in only meiosis because think about it. Why would it occur in regular body cells? Like, do you really want your cells to be different, like in different areas of your body? The reason the liver cell differentiates from like your hand cell is because just certain areas of genes are unlocked. And so in these like non-sister chromatids, like it's just exchanging information, and like the homologous chromosomes will have like different versions of the same gene, and like that's all that's happening. Obviously, crossing over is going to occur in metaphase too. Actually, let me just quick check this. Uh, Prophase 1. I am so off on that. According to my notes, synapses will cross. Oh yes, of course. I really wrote it down. The three synapses will cross over during genetic variation, so that's good. So now that we discussed crossing over, there really isn't much else to talk about. We have random fertilization, any sperm. Okay, if this is a male, this is all going to be sperm. Like your males are constantly making sperm. It's crazy. Like millions a day. It's what? It's actually crazy. Each of these are going to be different door to door because like what's going on here is like a different jet like crossing over than what's going on over here. So that's also interesting. So like you've seen the memes. It's like all like the sperm racing to the egg, and it's like who's gonna make it? Yeah, and then like the lucky person or sperm to make it, and that's like the one chance. I think the chance I looked it up. The chance of like two siblings happening in the same family, like if they're not twins, like just happening it by chance, it's like over 1 in 8 million. I mean, obviously Dream's odds of making a speed run with that Ender Pearl and Blaze Rod drops is even more insane, but 1 in 8 million is still on a chance. I mean, even with a population of 8 billion, in in any one of those families that exist on Earth, it's literally crazy to have a child. The dice rolls, and like an 8 million sided die, and it rolls on the same size. Like even if you have like 8 children, it's 1 in 1 million chance. It's like literally way too insane to even begin to comprehend. So with that, I'll be concluding this YouTube video. Once again, I hope you like and subscribe, and please buy Mr. Ham's products. We have a 90% off sale. I don't even know what we're selling, but we do have a sale. That's all I was told. Um, Goodbye. I'm gonna cut to the epic music outro now. Insert non-copyrighted music here.